This just in, math is broken. Maybe. Okay, today I'm going to show you a proof that tells us that 1 equals 2. That's right, the most absurd, ridiculous proof a mathematician can come up with, but I think I can prove it to you. And your job is to figure out, is my proof valid? Has math indeed been broken? Or am I somehow cheating the rules of math to manipulate my answer? I'll let you decide. Okay, here we go. So let's start by defining some variables. I'm going to define a variable A, and I'm going to define a variable B, and I'm going to say that these variables are equal to each other. So far, so good, right? I'm allowed to have two variables, and they're allowed to be equal. So whatever A is, it equals B. Whatever B is, equals A. Okay, here comes some algebra fun. Now I'm going to multiply both sides by the same number, and that number is going to be A. I can do that, right? Whatever I do to the left side, I can do to the right side. So if I multiply A by A, I get A times A. And if I multiply B by A, I get B times A. Okay, so good. Now, so far so good. Now I'm going to rewrite A times A as A squared. And we can clean this up a little bit. We'll put these in alphabetical order. We don't have to, but the order of multiplication doesn't matter. So I'm going to go ahead and write A times B. Okay, now again, I'm going to do the fundamental algebra move. I'm going to do the same thing to both sides. This time I'm going to subtract the same number from both sides so that they stay equal, but so that we can have some fun. So I'm going to subtract B squared from both sides. So I subtract B squared, and then on the right side I have AB, and I subtract B squared. Okay, now for some of you sharp algebra students out there, you might notice that we have on the left side a difference of squares. And if you look that up, you will find that a difference of squares can be factored as A plus B times A minus B. And you might think, Addison, this is where you're going crazy and breaking the rules of math. Well, let's take a look. If I simply distribute the A here to undo what I've did, I would get A times A, which is A squared, and then I would get A times negative B, which is minus AB. Then if I go ahead and distribute the B, I get B times A, which is positive AB, and then I get minus B squared. Well, what happens to negative AB plus AB? Well, those numbers, of course, cancel out. So we're left with A squared minus B squared, which, note, is exactly where we started. So this factoring of the difference of squares here is valid. If you undo it, it produces exactly what you started with. So it's mathematically equivalent. Okay, let's take back some of those strokes. Just wanted to show you why it's valid to factor a difference of squares as A plus B times A minus B. Okay, on the right side, the factoring is even simpler because we can just pull out a B from both terms, right? There is a B hiding in both terms. So we can go ahead and pull it out, and we can write B times A minus, well, if I pull a B out of this term, right, there'll be a B left over. So A minus B. Now, maybe you can start to see where this is going, maybe not. Now, I'm going to do something fun. I'm going to divide both sides by the same number, right? I'm allowed to divide both sides as long as I divide by the same number. So I'm going to go ahead and divide by A minus B. By A minus B. Now, if we have one number on top of a fraction divided by the same number on the bottom, that's kind of like 4 divided by 4. 4 divided by 4 is equal to 1. So similar concept, if we have A minus B divided by A minus B, that is equal to 1. So those cancel out. And on the right side, those cancel out. And now we're starting to reduce this to our final sauce. On the left side of the equation, we have A plus B. And on the right side of the equation, we're left with just B. Okay, now we're almost done. So remember that A equals B. That's how we defined these in the beginning. So I'm going to go ahead and substitute in B into where we see A, because I know that they're equivalent, have the same value. They're equal to each other. So I can rewrite A as B, and I know it will still have the same value since A is equal to B. So I can rewrite this as B plus B is equal to B. Okay, now we're almost done. What's B plus B? Well, B plus B is, of course, 2B, which would be equal to B. And now our final step, we're going to divide both sides by the same number. We can, of course, do that. That number is going to be B. So, aha, we have another situation where we have a b divided by a b, which of course is equal to 1. So that cancels out to 1. That cancels out to 1. So on the left side of the equation, we have left with 2. And on the right side of the equation, we are left with 1. Would you look at that? 2 is equal to 1. Is this valid mathematics? Does the field of mathematics need to re-question its most basic assumption that 1 is not equal to 2? Or have somewhere in here I broken the rules of mathematics in order to create an impossible answer? I will leave it to you to decide. Please post in the comments, what do you think? Is 1 in fact equal to 2? Is this a valid proof? Or are we cheating math in some way? And share this with your friends to get their opinion. And let's get to the bottom of this. Does 1 equal 1 or does 1 equal 2? The most fundamental of questions. Happy mathing. Thanks for watching and have an awesome day.